the world begins to behave in ways that feel unfamiliar. Objects lose their sharp edges. Certainty softens. Events no longer follow a single predictable path. Light arrives as both ripple and packet. Particles exist more as tendencies than as things. What once seemed solid becomes strangely fluid, suspended between possibilities. Welcome to the Sleepy Scientist. If you enjoy drifting through questions like this, you're very welcome to subscribe and join these quiet explorations. And if it's not too much to ask, I'd love to know where you're watching from tonight. Quantum physics did not begin as an attempt to be strange. It emerged because careful measurements refused to agree with familiar rules. Heat behaved oddly. Light arrived in unexpected ways. Matter itself seemed unsure of where it was or how fast it moved. What followed was not a rejection of reality, but a deeper look at it, guided by patience, precision, and a willingness to let go of certainty. Over time, this quiet framework revealed a universe built not from definite outcomes, but from probabilities. A place where events are shaped by chance within firm boundaries, where observation matters, and where the act of looking is itself a form of interaction. The quantum world does not hide behind mystery for its own sake. It simply follows rules that feel unfamiliar to human intuition. Tonight's journey moves gently through that world, not to solve it, and not to force it into neat explanations, but to rest with its strangeness, to explore how reality behaves when certainty loosens, and to notice what it feels like to let questions remain open. Settle in. Let the sharp edges soften, and allow the strange, quiet logic of the quantum world to unfold slowly. Quantum physics has a reputation for being strange, confusing, even unsettling. But when approached slowly, it becomes something else entirely. It becomes a story about limits, uncertainty, and the surprisingly gentle rules that govern the smallest pieces of reality. A story that does not demand answers, only attention for as long as it feels comfortable. So as the world outside grows quieter and thoughts begin to soften at the edges, here is a question to carry gently into the night. What if the universe, at its deepest level, is not built from solid things at all, but from possibilities quietly waiting to become real? At the end of the 19th century, physics felt settled in a way that is difficult to recapture now. The universe appeared orderly and cooperative, governed by laws that were not only reliable but reassuringly smooth. Motion followed clean paths, heat flowed in predictable directions, light behaved as a wave, spreading gently through space according to equations that had been tested again and again. There was a sense, quietly shared among many physicists, that the great structure of reality had already been uncovered, and that what remained were refinements rather than revelations. This confidence did not arise from complacency. It grew out of extraordinary success. Classical physics explained the workings of engines and bridges, the behavior of gases, the ticking of clocks, and the motion of planets with remarkable precision. It powered industries, illuminated cities, and gave the impression that nature, once mysterious, had finally agreed to be understood. With enough patience and careful calculation, it seemed that almost any physical question could be answered. Almost. The first sign of trouble did not arrive with a dramatic contradiction or an exotic experiment. It appeared in a place so familiar that it barely raised suspicion at all. It began with warmth. When an object is heated, it begins to glow, at first faintly, then more intensely as the temperature rises. Iron turns red, then orange, then white. Coals brighten, filaments shine. This glow is not decorative. It is radiation, emitted as the vibrating atoms within the object release energy into their surroundings. The relationship between temperature and emitted light was easy to observe and seemed, on the surface, easy to explain. This behavior was known as blackbody radiation. Classical physics approached